Hey everybody, welcome to our webinar today, Home Insulation and Air Sealing. I'm Joe Wachunas with Electrify Now, here as always with Brian Stewart. This webinar is being brought to you by Electrify Now. We're an all-volunteer organization promoting electrification as the quickest path to decarbonization and something we can all take an active part in achieving. And we're partnering with the Learn program, which is a San Diego-based workforce education and training program that offers free energy efficiency and electrification webinars. Check out their website, sanDiegoLearn.com, for really some amazing courses. We're going to highlight a couple of those in just a second. Well, today we are talking about, this is part of our Go Electric series, insulation and air sealing. And in this series, we talk about how electrification leads to lower energy bills, cleaner air, both indoor and outdoors, more comfort. We're going to be talking a lot about that with insulation today, and increased safety. And like I mentioned, Electrify Now is just one organization that works with San Diego Learn, but there's lots of amazing courses here. You can see some really great ones. One in particular for St. Patrick's Day today, but also want to highlight that DIY air sealing strategies to reduce energy use and money, and then one on tiny homes. So check out all the great course information from our partners at San Diego Learn. All right, Brian. So we're talking about a topic we haven't talked about before: insulation. Why is this important to electrification?
Thanks, Joe. And yeah, it's true. We're usually talking about equipment, but and like appliances and things like that. But this is an important topic, and I'm excited we're able to dig into this. I just recently had the experience of doing this in my own home, so I've had a little bit of a personal run through with this, which has been helpful as well. But if you just kind of look at some of the numbers, what the Energy Star will tell you that 9 out of 10 homes in the US are under insulated, which is a pretty shocking figure. But part of the reason this is the case is that codes for insulation have been getting more and more stringent across the country. So if you've got an older home, there's just no way that it's going to be up to code. It's going to be considered under insulated unless you've done some modernization work on it, like we did on our home. Our home has literally just turned 100 years old this year, so we know what this means. It's a kind of it's something you got to do every once in a while to keep yourself in code. And then the other piece of information that's interesting from the EPA is that insulating and air sealing can reduce energy costs by pretty dramatic amounts. It depends a lot on where you live in general, how much you're likely to recoup in cost savings. And this basically has to do with weather. So if you look at this map of the United States, for instance, that talks about climate zones, you can see that in the warmer areas, 1 through 3, the energy savings from making sure your home is air sealed and insulated are going to be modest. They're going to be under 10% most likely. But as soon as you get into the more colder areas, like we're here in the Marine area, number 4, not far from Eastern Oregon, which is number 5. Now you're talking about 12%. And obviously, as you get colder, you go into the northern parts of the country, your energy bills are higher. You're using more energy annually. Therefore, insulating and air sealing can save you even more money. It's kind of common sense. But I think this is a good way of thinking about what the potential is depending on where you live for some significant savings. And of course, it's going to depend on your home and all sorts of things, but this is typical what you can see. But there's also a lot of just not hard to quantify comfort improvements that come along with this whole idea of air sealing and insulating. And part of the reason I think most people get the idea of insulation. It's kind of like, yeah, it's like putting on a sweater when it's cold. It makes sense. But this whole idea of air sealing, I thought was really interesting and particularly relevant for our home because we had a relatively leaky home. But this is a kind of soundbite that you hear typically, that if you add up all these little gaps in your home, and we'll talk about where those gaps come from in a minute, it can add up to having like a big window in your home open. And nobody would think that's a good idea from a energy efficiency standpoint. But it also just means that there's stuff coming in your house that you don't want. So if you seal those little gaps. It's going to mean you have better soundproofing, so you're going to reduce noise from outside. You have better humidity control because now instead of either the dry air or the moisture coming in from outside, you can control what's inside. And then of course you get reduced kind of pollutants that are coming in, whether that's pollen or bugs and things like that, or obviously smoke, which is a big concern for us in wildfire country here, or air pollution if you live in a city. That's going to be a real determining thing. I remember when we had bad wildfire smoke here in Portland a few years ago. I mean, I could walk around with my indoor air quality meter and I could tell where the gaps were in my light fixtures and stuff, just by the ridiculous spike in air quality that would happen when I put the monitor near those lights that were leaking air or other gaps. So it's a real thing if you're trying to improve indoor air quality to reduce the number of gaps in your building shell. All right, let's talk about insulation first, but air leakage as well. If you just talk about where these losses come from when you're thinking about trying to keep the heat inside your building shell, you can see that typically a lot of those losses come from the ceiling, which sort of makes sense. Hot air rises, so having a nice blanket on top of your home is going to really improve your insulation. Windows are a factor, of course. Walls are also a factor. We'll talk about this a little bit more later. But air leakage, this is kind of what I think is often surprising. Depending on how leaky your home is, you can have as much as 25% of your energy loss coming from leakage. We've seen this in our home because we can see that on a windy day, when it's cold, our house gets noticeably cooler and less comfortable. The heat pump has to work harder. And it's because our house is pretty drafty, has been, till we had this work done by Jose, by the way, who we'll introduce in just a moment. But floors are another big source of energy loss. And then in the summer, of course, it's a slightly different situation, but it's essentially the same culprits. The ceiling, again, is going to be a big factor. And that makes sense, again, because imagine the sun baking on your roof and heating up your attic. That heat radiates into your homes. Windows become more of an issue, which is why curtains and shades can be a real lifesaver if you live in a hot area on sunny days. But again, air leakage is a big culprit, surprisingly large. All right, so because of those reasons, if you ask this is the Energy Star recommendations of typical measures that one should consider for your home. And you can see there's 6 of them here. This isn't the exhaustive list. Your home might need some other things, but these are, by and large, the big culprits. Insulation in the attic. Of course, we just mentioned that because of all those losses in your ceiling. Basement and crawl spaces in cold environments in particular. This is the recommendation in terms of the code, if you want to think of it that way. R30 for warmer climates and R49 for colder climates. We'll talk in a minute about what that really means, but it's a lot of insulation to get to R49. That's 18 inches or so. R13 for crawl spaces in warmer climates, R38 in colder climates. Again, it's just kind of showing that in colder climates, you need more insulation. For the air sealing ones, these last 4 are all air sealing. The recommended kind of test for determining whether you've got a good sealed home is called ACH 50. We'll talk about that more in a minute. But the recommended measures are attic air sealing, that's a big one. Basement crawl space air sealing, that's probably another big one. And then there's lots of places throughout your home that you can find little air leaks. We'll talk more about that and seal all those tiny little cracks up. And then of course, windows and doors is another big one. So these are the 6 most common kind of prescribed measures for insulation and air sealing in homes. And we're going to talk more about all this more in detail with our panelists in a minute. Okay, I just wanted to give a little idea for people about what R49 means. If you peek into your attic, and if you've got insulation in your attic, you can jump up there, take your tape measure. If you've got 5 or 6 inches of insulation up there, which is kind of equivalent to 1 bat of insulation, if you're thinking about a fiberglass bat, 4 to 5 inches, that's R15. So if you think about it, you're going to need twice that, or almost twice that to get to R20 and 21. To get to R49, which is what they recommend for colder climates, even here in Portland, R49 is recommended. 16 to 18 inches deep of blown insulation, or that's probably three to four bats worth of insulation if those bats are in good shape. So it's a lot, I mean, just tossing one layer of insulation up there is not going to cut it in terms of what's recommended in most areas. Okay, and then there's another, and we'll talk more about this with our panelists as well, but another thing that's kind of decision that you might be faced as a homeowner is what kind of fiberglass to use, or sorry, insulation to use. Should I use cellulose or fiberglass? Fiberglass used to be kind of the standard, but more and more cellulose seems to be preferred. And again, we'll dive into this with our panelists, but in general, what people will say is that the cellulose has a little higher R value per inch of thickness. It's heavier though, so it's a little harder to work with. It's got better fire resistance in general, and it's more sustainable. Most people would agree, and largely just because this is recycled material. It comes from, recycled clothing and other sorts of cellulosic fiber that can be readily used for insulation. It's also great for sound reduction. Fiberglass has been the go-to one. It can be lower cost. It's a little bit more resistant to moisture, which I guess is an advantage, but if you've got moisture problems, you need to deal with those. Your insulation should not be dealing with should be your solution for moisture problems. You need other solutions. It's lighter weight. It's a little easier to handle if you're doing this yourself. But it's also kind of like, you got to really be careful with both of them about breathing this stuff, but particularly with fiberglass. Okay, so let's talk about this ACH 50, what that means. You recall that's what the standard was for these measures. It refers to this idea of the air changes per hour in your home at 50 pascals of pressure. 50 pascals of pressure is a little bit of an arbitrary number, but it's essentially equivalent to the sort of pressure difference between inside and outside your home on a really windy day. It can be something like 50 pascals. But the way you do this test, you can't just do it on your own. You need this sophisticated equipment. You need a blower door test to be done. And what you do is you close all the windows and doors. You put this sealed fan in one doorway and turn the fan on, which is capable of creating huge amounts of airflow. And you measure the airflow that's required to get this pressure difference between the inside and the outside of your home to be 50 pascals of pressure. And using that number and knowing what the inside air volume of your home is, that you can calculate the air changes per hour. And just for reference, like a new home, sometimes there's code for this, sometimes there's not, but in general, new homes all across the country are going to be built at 3 air changes per hour under this ACH 50 test or less. I mean, it can be down to 1, but older homes like ours can be 10, it can be more, it can be 15. It can be quite high. If you've got an older home that's not air sealed, it's in old windows and doors, it's not uncommon for homes to be as high as 10. And so that is a huge disparity, which comes into play when air sealing your home and looking at those measures that can make a big difference in terms of energy efficiency. All right, so again, we'll get into more of this with the panelists, but just as an overview here, like, where do these leaks happen? Well, there's lots of them, but basically, anywhere in your attic that isn't really sealed up tight, that's a big source of air leaks. And of course, most attics have some kind of doorway or hatch to get into them that also need to be sealed up really tight. Otherwise, you're just bleeding air into your attic, which is an uninsulated space. All the vents in your home, think of your bathroom vents and your kitchen vents, etc. Those can be leaks because if the dampers don't close well on them, you can basically be letting cold air into your home. Then there's all these little joints between different kinds of building materials. And a big one is around the place where your basement and foundation meets the woodwork, the joists that start the framing of your home. If those aren't insulated really well, you can get a lot of air leakage in there, which is a common problem. We had that in our home. And then, any kind of protrusion, anything that goes through the wall, think of like a plumbing, like an outdoor faucet, that is likely going to be a source of air leaks if it's not sealed up tight. And then anything around edges and doors, like windows and doors, etc. So there's lots of potential culprits, fireplace dampers, etc. So being able to locate those is tricky, but there are ways to do it. Some of this you can do yourself. You can get one of these little thermal imaging cameras. They cost a couple $100. They're pretty amazing. And you can walk around your home, and just with this image, you can see the places where you see this big temperature difference. Anything that's cold, if you're doing this on a cold day, anything like a window, for example, is going to show up blue or purple. And anything that's warm, like roughly indoor air temperature, is going to show up as red or orange or yellow. So you can see these examples. This image is showing that this electrical box, this is one from, it looks like from the UK. It's not an American style box, but you can see that's showing cold. So there's cold air, either a lack of insulation or an air leak, an air gap that's there. You can see around the edges of doors and windows is a typical place. This is probably an attic hatch that's got some ceiling issues. Here you can see there's some insulation that's just missing in a ceiling and other cold spots, etc. So that's a good way to do it. With a blower door test, like I mentioned, once you have that fan cranking, you can walk around the home and you can feel with your hand places where air is coming into the house. I've noticed it in our house. You can see it with some of our can lights in our ceiling. And like I mentioned, some of our electrical sockets. If you don't have either of those two things, and if you do have a windy day, particularly if it's a little bit chilly, you can walk around your home with an incense stick that's making a little smoke. And if you put it in various places, you'll see where the smoke is being disturbed. You can sometimes identify leaks that way in a kind of DIY hack. Okay, so if you are into the DIY mode, there are things you can do. And like I said, there was that other webinar that's all about this that was advertised earlier on the program. We'll send you the links, but you can put in attic insulation yourself. It's totally doable. Again, it's a messy job. You can do things like replace can lights with sealed LEDs, because the issue with a can light is that it's like the old style had to ventilate into your attic or whatever, because there's a lot of heat that's created by your light bulb. New LEDs don't create that heat, so they can have sealed enclosures. So you can basically stick this insulated sealed LED can into the same opening and replace that incandescent bulb, which will also save you some money, with an LED fixture and reduce leaks that way. You can go around this is a typical place where you might see leaks around the edges of ducts where it meets the flooring. You can do this with electrical sockets. I just did this over the weekend in my home, by the way. It's a messy job. I mean, be prepared. It's messy. Make sure you got gloves. You're going to get this foam all over the place. The pros are really good at this, but I can tell you, I made a big mess. I had to go back and paint a bunch of stuff. So it's messy, and you can get these little insulation foam things that go behind the electrical sockets. This can definitely make a difference, but be prepared. It's a messy job. You can also do that foam insulation around any kind of external plumbing vents. And of course, putting on door sweeps and stuff like that is something you can do yourself. And weather stripping around doors, that's something you can do yourself, again, if you're into the DIY stuff. But I will say that even if you do a good job at this, you're likely to miss things that a pro is going to find. They're going to go in your attic and find air sealing problems that you're never going to see. And they're going to be able to make sure that your insulation is working properly with the ventilation that's required in an attic. So I'd say, yes, there's a lot you can do yourself, but I don't think it's a substitute for having a pro do it if you've got a big job on your hands. All right, so if you're trying to find a contractor, this is one outfit that is pretty reputable, that has, very reputable, I should say, that has outlets across the country. So it's a good sort of national resource. There aren't very many national resources. In California and Washington, the Switch is On has really good listings for people who do this kind of efficiency and weatherization work. Here in Oregon, Electrify Oregon has a list of contractors that do this. You can filter by insulation. HomeRx is one of the ones that comes up. Our panelist today is from HomeRx, for example. And then incentives. This can be expensive, this work, if you have an older home like ours, but there can be really good incentives. Again, the Switch is On is a great locator for incentives in California and Washington. So I know that some of you are tuning in from the East Coast. I don't have resources for you, but your utilities often are a good place to start. California has this great Go Green financing option where you get relatively low interest loans for home efficiency upgrades, including insulation. And then here in Oregon, there's really good incentives from the Energy Trust of Oregon, which collects money from ratepayers and then pays back with incentives for insulation and other home improvement measures. So there's money out there. If you you just have to look for it. Sometimes the contractors you work with will be able to point you to the incentives that are available. All right. So speaking of contractors, we're really excited to have Jose Benitez with us today. He's the president of HomeRx. HomeRx is an industry leader in insulation and weatherization services, serving the Pacific Northwest. And Jose has nearly 3 decades of experience in this industry, improving home comfort and energy efficiency in homes across the Pacific Northwest. He's an expert in the role that insulation and air sealing plays in the building envelope, and he understands how various types of insulation can affect comfort, performance, and sound suppression. And under his leadership, HomeRx thrives with a dedicated team of experts. I can vouch for that. We had them running all over our home, and I was amazed at the amount of work they were able to do in a very short time. They got this fleet of skilled installers and commitment to helping homeowners maximize the benefits of upgraded insulation. So with that, I'm going to stop sharing and welcome Jose to our program today. Thanks for joining us. We really appreciate it. And yeah, why don't maybe just to kick us off, why don't you tell us a little bit more about HomeRx? I mean, I did the top line intro there, but why don't you just jump in and tell us a bit more about the work that you do?
Well, hello. Thank you for the invite. Thank you for the kind words as well. Yeah, so I'm the president of HomeRx. I've been doing this for a little while, as you've heard. We are a weatherization company. We go and we find any way that we can make your home more efficiently. And that is through air sealing, insulation, looking for any gaps, doing whatever we can to save as much energy in your home as possible. We have several different types of installations, products, ways to figure out how to get that done in your home.
Thanks, Jose. That's great. All right, so maybe let's dive into what is the process for assessing a home's insulation and air sealing needs? How do you get started and understand what does a home need?
So we like to go into the house and we end up, we do visual checks. We go up in the attics, check the walls, go underneath the crawl space. We have, different tools, infrared cameras, thermal imaging cameras. We look for, do you have insulation? How much insulation? Is it in a poor shape? Do we have access into different areas that maybe are not visible on the inside? But we do a thorough check as we, make our step into your home to figure out where are these leakage, where is the insulation that might be missing or is missed, or you have none, and we go into every little nook and cranny to find that.
Can you give us an idea about how long does a typical assessment take? What would someone expect that to look like?
When we do a visual assessment, it probably takes us a good, 30, 40 minutes or so. We also have an audit process. that when we come in there, we actually do a full gauge and audit in your home. That typically that will run anywhere 3 to 4 to 5 hours. You know, it kind of depends on how big your home is, how many levels, and you know, it takes a little bit of time to do certain protocols and procedures that we need to do.
Gotcha. And then is that, so it sounds like is it true that typically there'll be kind of like a visual inspection and that you do, and do you charge for that? And is there a different charge for the kind of more thorough audit?
Yeah. Our home assessments usually is we don't charge for just a home assessment. We go in there and do a visual, something pretty simple that we will let the homeowners know. When we go in there to do a full energy audit, there is typically a charge for that, and it'll range again just by the size of your home, how long that takes. And that there we do that those are the ones that it actually takes anywhere from 3 to 5 hours or so to do the whole audit. We come in with thermal imaging cameras. We take lots of pictures. We actually build a nice big report to give as much information and find out information for the homeowner and what we suggest and what we should do for them.
Gotcha. And that's where, so like in a full audit, would you do a blower door test in that kind of situation?
We would do a blower door test. Yes, we'd like to do our pre-numbers to figure out where we're at. Mm-hmm. And then once the scope of work is made, we go and do the work. We do a post test, and then we figure out, where we end up. So we like to see the lower numbers, the better. In certain instances, the testing, depending on the testings that we do.
Great. And I think this is a great spot to launch into that, because we've got some slides that show a little bit about these reports that you give to homeowners, Jose, and some of the differences in numbers. Yeah. So tell us a little bit about this. Looks like one of your energy audit reports.
Yeah, so there are energy audits. What we do, take a picture, we go around and we make sure that we get as much information as we can. As we're going through the home, we make our assessments, and we put all of this information that we get into our program here, and it gives us it gives the homeowner lots of information on what their home is at the time of our audit. It gives you a bunch of specifications. It gives you lots of concerns. When we go in, as we're doing our audit, we do take lots of pictures, and we gather all this information. We measure the home, measure the attics, the crawls, whatever we can to plug in this particular program.
Right. I remember this. So this page here kind of gives you an idea about how much energy you're using. And I love this sort of like what you think you might be able to achieve with the goal, right? And
yes, usually when we do our initial audit, we always plan to make sure what we can do to see your energy meters go down as much as we can, and doing our air sealing processes, our insulation installing processes, and all of those procedures. It's this particular program is very good. It gives you lots and lots of information, and doing this a long time, sometimes I get a little weird, not nerded out, I guess, so to speak, just because it has all of this information that's actually pretty cool.
Yeah. So then this is the list of the recommended measures, right? That you're offering.
So once we put all these informations into our system, then it kind of gives us it takes a general idea about how much it costs in your area, depending, what area you're at. And it gives you it gives a homeowner an approximate cost of how much it's going to cost. the savings you have, your rate of return, the payback in years, and again, that way we're building out, a great detailed report, and especially at the end of the day, like when we find out and we see our rate of returns, our annuals and savings, like that's huge. Insulation is one of those things that when you do insulation and other measures that give you efficiency in your home, it actually pays you back in the long run.
Gotcha. I mean, in this case, it looks like there were some pieces of equipment in the home that you recommended upgrading, like the kitchen fan, the bath fan, and the refrigerator, for example. Those were like appliances or things that just either weren't working or were just needed to be upgraded. Is that right?
That is correct. A lot of the kitchen fans, we go into homes that are, 1900s or, early 50s, 40s, like every year. And sometimes they're still working using the same appliances from back then. And sometimes they're not working very well. Sometimes they don't work at all. When we come up to particular appliances like that, if we can repair them, we like to give the option to repair, so that we actually get proper circulation, proper, bad air out, fresh air in, while we're in the home,
right,
making it more efficient.
I wanted to zero in on these because these measures right here are the ones that have the biggest bang for the buck in terms of annual savings. It looks like the costs to do these are very low, but and you had this on a different page of your report, I know, but this includes these huge rebates from the Energy of Trust of Oregon in this case. That's why these numbers are so low. They would be more like, close to $10,000 otherwise.
Yes, the Energy Trust of Oregon, well, back up a little bit. So yes, to insulate your attic and your crawl spaces are, again, biggest bang for your buck. You get the highest energy savings, and because that happens, the Energy Trust of Oregon does have rebates to help homeowners with this cost. And it is one of the easiest and best things to do to help out really quickly. And with the help of the ETO rebates, we are able to help and service a lot of people.
Yeah, I mean, this is pretty amazing. This payback, I mean, even 5 years for payback on something like this, that's pretty amazing.
It is pretty crazy when you sit there and you think about it. Again, like the investment that homeowners put in their home for energy savings, like it literally pays for itself.
Yeah.
Great. I think, Brian, there's a couple pictures, right?
Yeah, but this is the other one that I wanted that I thought was interesting because it sort of just gives you a pretty good idea about the energy savings for the whole project. So this is kind of like your total energy costs, expected energy costs, and so saving almost $500 a year.
Yes,
that's pretty amazing.
Yeah, it's again, it's kind of hard to for some people to envision that, just because like you can't see it, you can't touch it, you can't always put your finger on it, but it is behind our sheetrock and underneath the crawl space, and it actually is saving you money and making you money at the end of the day. Again, this is one of those crawl spaces that we go into there on the before pictures. There are some crawl spaces literally like that, look like that throughout the whole, everywhere, I'm assuming. We go in there, we remove a lot of the debris and garbage and stuff, and we make them look like that afterwards. Using Energy Trust of Oregon rebates and stuff, they do have a specification manual where we have to abide by their specifications. We do all of our jobs to that and above, so we make sure that at the end of the day, our clients get what they paid for, let alone making sure that our insulation that we install, our air sealing and all that, has longevity and we do what we say.
Yeah, I know. I mean, in our case, we definitely had some pest intrusions in our crawl space, and which were destroying some of the insulation. And your guys did a good job of cleaning that up, of course, but also I think like helping to make sure we don't get, like sealing up the areas where the pests were getting in. So, hopefully that means that we don't have those problems going forward. So I think this is in crawl spaces, it's like nobody wants to go down there. But when you do, it's like it can be shocking what you find, right?
100%. One of the biggest things, sometimes people don't even know that they have little critters under there, right? Critters can get in, they can poke into one of your crawl vents, and they can literally make a mess down there. Let alone, get in a possum or a raccoon under there that can make even more of a mess.
Yeah.
When we go down there, we try to make sure we can fix all of those things as well to help keep those little critters out. Attic insulations. Obviously, the before picture here is an attic that we actually removed all of the insulation from the attic. Couple of reasons. Sometimes they have rodent problems. Sometimes the material is maybe it's been smoked, or there's been some water damage or whatever, that we have to remove all of the insulation, which gives us great access when we come back to do all of the air sealing. Because at this particular point, we can literally hit every little nook, crook, and cranny with our foam and other, products and materials that we use to look for all of the gaps and holes that are in the ceiling.
Yeah, I think that was I know in our house we had that experience. I was like, well, why would you take the insulation out that's there? But once I started thinking about this air sealing thing, it's like, well, yeah, you can't air seal very well if you've got a bunch of old crappy insulation in there, because you can't find the places where the gaps are. So removing old insulation can be a really good idea, I think. So
Jose, is there any difference in air sealing from above, with the attic versus air sealing from below in the house? Are they both good if you're foaming from below?
Um, it's it's a little bit more difficult when you're below, just because, I mean, at that point you're taking off, the any kind of fixtures up there, because we don't want to put foam around the top of a chandelier, or we don't want to see it
Yeah.
from the inside. So getting it from the outside, most of the time we could actually see the gap from where it was cut from the sheetrock, where that's where we make the best uh, job at getting it completely sealed.
Got it. We've got a lot of questions, just FYI, in the chat that we should start getting to, but I know we got a couple more slides.
Yeah.
So, Jose, what's this? Is this what's this structure here?
That is a skylight.
Okay.
So if you look to the one right to the left, that skylight, that insulation came off. So when we come back and we start doing the work, we have to make sure that those skylights are also insulated. We also have that white thing, paper-looking thing over it, which helps with the air infiltration as well.
Gotcha. And then this is the blown insulation that you blew in afterwards.
Yes, and that is our finished product. The one there on the corner, this particular homeowner wanted a attic storage up there, so we ended up kind of building up some plywood there and build up some platforms, and we gave them a small storage area.
Gotcha.
Our blower, or when we go out there and we do our audits and stuff, one of the things that we like to do is we like to get our pre-numbers, so to speak. We'll put the blower door in. The top number there on the right-hand side is the air leakage of the house for CFM. So this particular house, the leaking was 4,300 CFMs. After the work was done, and all the work that we did, we come back and we do a post number to see where we ended up at. And this particular house we got it down to 11, almost 1,200 CFMs.
That's
Wow.
amazing.
You cut it by something around 75%. That's amazing.
Yes, again, people sometimes don't realize how many uh, penetrations they have in their home going up into, like they'll have some big soffits that are completely open. Underneath their crawl spaces, they have huge, they have a big hole for a tiny little pipe. It's pretty crazy.
And then we didn't talk about this in the intro, but duct sealing basically is a whole nother area where you can see some pretty big efficiency gains if you seal up leaky ducts. So tell us about this, Jose.
Yeah, so our duct blasters, so when we have a forced air home, the air that is coming through your actual ducts, a lot of them are metal, some of them are flex, but as your air is flowing through those ducts, we want to make sure that you have all of your air coming through your furnace and out those ducts. And in a lot of cases, we go into certain homes that their ducts are disconnected. They can be disconnected by an inch or so, or they can be literally like completely disconnected. This particular one, we had a bunch of disconnects, which the number there, the 633 CFM leakage, we had lots of disconnects. So what we do when we go under there, we make sure that all of the ducts are connected, screwed, and then we mastic every joint that we see from plenum all the way up to the supply duct. So that way we make sure that all of your air is going through those ducts and not being leaked into your crawl space. The bottom is just the number that was our post number where we reduced the leakage by 500 CFMs.
Yeah, that's amazing.
Great.
Awesome. Well, great.
I've got a good question, Jose. We're getting a lot of questions. Maybe we can start getting to some of them. So some folks are talking about their exterior walls can be challenging. One person's mentioning they've got metal siding. Another group is saying, we've got brick on the exterior, and they're worried. They've heard that if you put in the insulation in their walls from the interior, that's a big mess, and somebody says even a nightmare to do that. But what do you think if folks are worried about their insulation in their walls, but they have an exterior siding that's challenging to take off or pump insulation in?
Yes. If we can remove and replace the siding, that is where we like to go first. So there are some sidings that are challenging. Aluminum siding is challenging for sure. They bend little kinks really quick, and sometimes it's just a little bit difficult. We do have some tools that help us, able to remove that. But again, sometimes there's little dings and creases that are made just because it's an aluminum siding. Vinyl siding is another. We have particular tools that we are able to pull that off. We also have to be very careful because sometimes they get very brittle. Wood lap siding, we can remove. Shakes, we can remove. There are some sidings that we can't, like they are like T111s, that there is no pulling away from the house.
What about brick? Two people were asking about brick.
Yeah, we don't do that. What we'll do if we cannot do it from the outside, then we'll come in on the inside, and then we'll have to do some drill and fills. We will drill through the sheetrock. When it comes to lath and plaster, we have to have a good conversation because lath and plaster is an art that not very many people around here can do anymore. So we will drill, fill, and usually we will try to leave paint ready. So we'll primer.
How big a hole do you have to drill from the inside through the sheetrock?
We typically do 2-inch holes throughout your whole home, right? So every cavity that we see, you will have a hole in every cavity all the way around. So some people get a little scared because it just looks like Woody Woodpecker came in and had a heyday in your home. but that's the only way that we can get into those
Mhm.
homes.
Yeah. I mean, with sheetrock, it's pretty easy to patch that, I would guess, right? But with lath and plaster, yeah, I can see why that would be trickier. Yeah.
Yeah, it's a little bit tougher for sure.
Yeah. Yeah.
Another question from our friend John Washashinsky on Windows. I know this may be outside your area of expertise, Jose, but John's wondering, if you have single pane windows, is that an area where you could see some bang for your buck in replacing those, especially for comfort? Any thoughts on that?
In my opinion, when we're talking about your bang for your buck, windows, because they're typically very expensive, and if you're looking at the whole wall in general, if your walls do not have any insulation, the cost of installing insulation on all of your walls versus the 15 windows that you might have, if you look at those two costs and look at your rate of return, you'll actually see that the insulation at a lower cost for the install is going to save you, and your rate of return will be a lot more quicker than you do on your windows. Not saying that windows are not a good thing to do, but I would probably do those at the end, in my opinion.
Okay. So
Are you familiar with we should probably, uh, anyone who's interested in the kind of have this older window problem, the Indow, we can put a link in the chat. Indow is an interesting solution for kind of basically it's a way to make your windows into double pane windows relatively inexpensively. It's an inside custom sized acrylic window insert that for the most part you're not going to be able to notice. They're pretty interesting. It's worth checking out if you're in that situation. A lot
Indoor
cheaper than new
windows
windows.
is a great way to preserve, especially like historic windows where we can't touch them, but they're just single pane lead windows that they need help. Indoor windows, they'll custom fit right inside. They're a full screen. You clip them in. Great solution for that for sure.
is it the best idea to get an audit in the coldest months? Chris is asking, so you can see, leaks easier.
Not necessarily. There are certain ways that we can figure out, to get your home. If your home is, if we're in the summer, so to speak, there's typical ways through a thermal camera we can tell where the sun is beating in, and you can say that that's a hot spot. So we would figure out that if it's cold outside, it would be cold there. So either or, we can look and see where your biggest weakness part is in your home.
Right. Hey, another question we get a lot is, if because we're electrification focused, and that generally means, eventually heat pumps for heating and air conditioning, and there's this question sometimes that comes up, should I insulate first and then put in a heat pump, or should I put in a heat pump first and then insulate? I know you and I had a good conversation about this the other day, but what's your thoughts about what those order of operations should be?
That is a great question. It's almost sometimes it's like, was it the chicken or the egg, right? I mean,
Mhm.
there's a couple of different ways to think about this. Now, being an insulation guy and knowing enough about HVAC that gets me in trouble. For me, if I am speaking with a homeowner and they are thinking about also getting an HVAC or getting a new, heat pump or whatnot, uh, make sure that they give the person, the company, the HVAC company, uh, what they're going to do with the insulation. So the HVAC company can run the proper manuals to make sure that they don't oversize the home. So usually I say, look, if let me give you the proposal of what we're going to do in your home, share that with your HVAC person, and then make sure that they they uh, they manual J it to what your actual what you're going to put in your house. Um, I also like to say, like, we like to be the last ones out, right? So if they're going to be up in the attic running ducting or whatever, electrical, whatever it may be, have us be the last ones there. So when we leave it nice and level and perfect, and we hit every little hole, nook and cranny. So, we're not, you know, creating a mess.
Yeah, yeah. No, I think that makes a lot of sense because, if you think back to those pictures with all that blown insulation in the attic, I mean, if you're trying to then put in a ducted mini split in your upstairs bedrooms or something like that, you just got to ruin all that good insulation in order to put that in. And then are they going to put it back in? Well, I don't know. So I think this makes a lot of sense. Get your quote for your insulation work, share that with your HVAC person so that maybe you get a heat pump that's a half a ton smaller than it would otherwise have been, which will save you money and will operate better. And then have the HVAC guy come do the work and then do the installation work. I think that's makes a ton of sense. Makes a ton of sense.
100%. I'm with you for sure.
Hey, Jose, we've got such good questions, and please keep them coming. One type of insulation we didn't talk about yet is spray foam. In my house, we vaulted our ceiling a couple years ago, and there wasn't enough room to put in. We'd put in a little dense pack cellulose, but we had to put in spray foam to achieve the R values that were required by code. Um, in the environmental community, spray foam folks are a little bit conflicted on it because it has a high it costs a lot of energy and produces emissions to produce spray foam. But what are your thoughts from a installer perspective on spray foam? Do you do a lot of spray foaming?
We do some spray foam, yes. And one of the biggest reasons that we do the spray foam is spray foam, it does have the highest R value per inch. So when we need to reach the R value that is required, and we only have a very small area to fill, then the spray foam comes in very handy because at that point, we can fit a lot of R value in a small 2x.
Got it. Okay, so that space is one of the biggest drivers of spray foam. Is it usually more expensive than other options?
Yes, it is more. It is very expensive to do spray foam, and it also, because it's expensive, it has a lot more things to the spray foam. Usually we use a closed cell spray foam. It adds the fire retardant barrier, air barrier, moisture barrier. It actually gives a little bit of structure up to 2 inches. There's a lot of things that go in with the spray foam as well. But yeah, it is one of our most expensive materials that we do and use.
Okay. Here's another good question from our friend John Washtinsky about air sealing, and at what point does a home become too tight, or at what point, maybe the way to think of it, return air vents and air exchange systems become important at some point. But what is that? Where's that kind of threshold where you have to start thinking about adding ventilation to a home because it's sealed up so tight?
Right. So when we do our calculations, there is, very leaky and there is very tight. And we like to stay right around the not so leaky, but not tight. When we do go into really tight mode, we do have to figure out about some kind of a venting, mechanical air coming into your home from the outside. There's a couple of different ways to do that. Simple way to do that, we add a continuous fan in a laundry room or a bathroom. Sometimes we talked about ERVs and installing one of them. We've gone to certain specific ones where we literally do an AirFresh 200, which is just a little vent in your wall that just allows fresh air to come in, and it's with your mechanical on, it circulates the air in your home. So there's a couple of different strategies to do that.
ERV, this stands for energy return ventilation or something like that. Is that right? So it basically means that when the cold air is coming from inside your home, that it gets warmed up by the warm air that's going out or something like that, so that you don't lose a lot of energy.
Yeah, that's an HRV that takes the cold air from the outside or the hot air, depending on the season, and it'll warm it up or cool it off as it goes in your house. And then they have another the exhaust that takes your stale air, so to speak, inside and helps it get out.
So it's always bringing fresh air, but you don't necessarily lose the heat with that fresh air.
With an HRV, no, yes, it'll temperature, it'll get it to temperature before it's going up.
Okay. Great. Brian, I think we've covered a lot.
There's a question here about low income folks. I'm not super up to speed on this, but Jose, what do you know about? I'm pretty sure here in Oregon, and I think it's the case in all across the country, that income qualified homes, there's more money federally and also from local energy efficiency programs to make sure low income folks get good weatherization services. What can you tell us about that?
Low income. So here in Oregon, we do have agencies that help the low income, and it's all based on their income. They do pretty much come in there, do a full, complete audit and inspection, and they also are able to give the homeowners from HVAC, insulation, air sealing, all that stuff. And there are programs, depending on where you live, they're either run by the county, or we also have some PUDs that also help with that. We also have a program here in Portland that is also helping out with the low to moderate income folks. So there are many ways out there to help your clients or customers if we're looking for some help.
Awesome.
We're a company who's lucky enough to know where we're able to help. Again, Energy Trust of Oregon, low income agencies, PUD programs that they have. There's ways to help for sure.
Awesome. Well, I was thinking maybe as we're getting to the top of the hour, Jose, are there any examples that come to mind of clients that had a leaky house or no insulation, and then you were able to help them out? And we saw a couple of those readings before where you're cutting the energy use by 4 or 5 times. But share any personal story you can think of folks that have.
Yes, one of my favorite stories that happened several years ago. I was in the Southwest area. A big home over the top looking over Portland. And this was a pretty big home, about 4,000 square feet, 3 levels. And I went in there to do just an assessment. They had very little insulation in their attic. I mean, very little. They had no insulation in their crawl space, no insulation in their walls. And they were spending $800 to $900 a month just in the heating and cooling. I went in, I talked to him about what we do and yada, yada, yada. And the gentleman was kind of a little skeptical on, the insulation when, I said, look, like, this is what we can do. And he looked at me, he thought I was crazy. He goes, well, how much do you think you can reduce my bill from? And I was like, look, if you're spending $900, I said, I could probably save you, I don't know, maybe $300, right? I don't know. I'd have to do the actual testings and stuff like that. So anyways, he's like, well, okay, fine. Got the job, started doing the job. Took us about a week and a half to do the whole job. Paid everything. And I started this home in September. We finished it a couple weeks in. In April of the following year, I got a huge basket with lots of fun goodies, lots of fun drinks, several gift cards, and the homeowner had thanked me and said that I reduced his bill by more than half by doing everything, and he did not believe me, and we did it. So insulation does work, and it was a good feeling that somebody actually did that. So love that. Love the story. We still chat every once in a while. I go up to his house and friends and stuff like that just to make sure that they're taken care of. So it does
That's
work.
great. I love
That's
that.
great.
Yeah,
That's really good.
yeah, that's awesome. Yeah, wow, more than half. That's incredible. Yeah.
That's pretty amazing. Well, maybe one last question for me, Jose. I think we kind of covered it, but just off the top of your head, like what do you find, or generally speaking, what are the biggest bang for the buck measures that you do, like day in and out when you do this? You just know this is going to have a big impact. What are those things just off the top of your head?
Top of my head, we want to air seal the attic, insulate the attic. We want to air seal the crawl space, insulate the crawl space. Those are the best things to do right away. And you're ready to return the savings that you get just in those two things.
So,
Phenomenal.
and folks, yeah, so the folks that were worried about their walls a lot, maybe it's like, hey, look at your crawl space and your attics first, because that's
Yeah,
you.
it sounds like it. Yeah.
Yes.
Yeah. Great.
Awesome. Well, Joe, any other thoughts before we wrap
No,
up
this
here?
is fantastic, Jose. Thanks so much for being on. Thanks for sharing your expertise.
Thank you.
Thanks to everybody joining us. If we
And
missed anything, we'll put our emails in the chat. You know where to find Brian and I.
yeah, and we'll be sending up a follow-up email to everyone who registered with a bunch of links. And if you have questions that we didn't cover, feel free to email us. We'll try to make sure we get your questions answered. And thanks everybody for tuning in. Thanks so much, Jose, for being with us today. That was super helpful. And we hope to see all of you on upcoming programs, and good luck with all your electrification projects at home.
Thanks all.
Thank you.